So we'll start with the problem. Prepare to find tension carrying capacity of single angle section disconnected to the gusset plate. So first of all, we'll write down a problem. So find tension carrying capacity of single angle hundred by 6 mm connected to gusset plate. By 22 mm diameter. Five bolts at 66 mm center to center. In one line. Fy equals to 250 Newton per mm square and Fu it is 410 Newton per mm square. So now we'll go ahead to the solution part. We need to carry out the tension carrying capacity. So first of all, we'll just draw a diagram. So this is the gusset plate that is 12 mm thick. And now we need to draw the 5 bolts. It is already mentioned that 22 mm diameter bolts at 66 mm center to center in one line. So these are 22 diameter. There are 5 in numbers, and center to center distance, that is 66 mm. So this is angle, that is 100 by 100 by 6 mm. This is a gusset plate, and this is a so we'll proceed with the step number 1, that is to calculate cross section yielding. We'll be again referring what are the clauses related to the IS 800 and accordingly what we need to calculate. We'll basically calculate cross section yielding, net section rupture, and then block shear failure, and whatever the least values we will get, that will be considered as the design tensile strength. So step number 1, that is cross section yielding. So to calculate cross section yielding, we just need to refer clause 6.2. So this is the clause 6.2, design strength due to yielding of cross section TDG, that is equals to AGFY divided by gamma MO. Fy we got, that is the yield stress, then Ag is the gross area of the cross section, and gamma MO is the partial safety factor. Fy divided by gamma MO. This is from clause 6.2. Page number 32. So first of all, we will calculate Ag, which is not given. So therefore, Ag is equal to, so gross area, it has to be, so you have this leg, This is 100 mm. And this is 6 mm. So 100 plus second leg. If you just consider this leg that is of 100 mm, so second leg we'll just need to deduct this 6 mm. So that is 100 minus 6, and this is to be multiplied by 6 mm thickness. So here if we calculate, you will get it around 1164 mm square. So therefore we can calculate TDG. This is equals to F5 we already given 250 multiplied by 1164 divided by gamma MO from the table number 5, that is 1.1. So if we calculate this, you will get 264.55 kilonewton. Then we'll go ahead with the step number 2 calculation, that is net section rupture. So step number 2, that is net section rupture. So it is again from the page number 33. That is clause number 6.3.3. So we have this 6.3.3 single angle. TDN is given by 0.9, that is the design strength as governed by the rupture at net section. That is equals to TDN equals to 0.9 NCFU by gamma M1 plus beta AGO Fy divided by gamma MO. So beta, value of beta is also mentioned here. What exactly beta means? So that is 1.4 and minus 0.076 into W by 2 into Fy by Fu into Bs by Lc. What exactly these parameters are, that we will be seeing. So this has to be less than or equals to Fu into gamma MO by Fy into gamma M1, or it has to be greater than 0.7. W it is called as the outstanding leg width, while Bs it is the shear leg width, and then we have this LC, that is the length of the end connection. So we can even just check what exactly AN means, that is the net area, the net area of the connected leg ANC, AG is the gross area, and T is the thickness of the leg. So this is how this angle with single leg connection, it has been mentioned. Thickness W is W1, this is BS equals to W. So we'll write down a formula. This again you can write down, this is from clause 6.3.3. Okay, 33. So TDN equals to 0.9 FU ANC by gamma M1 plus beta AGO Fy by gamma MO. So that's the formula, and we need to calculate step by step. First of all, we'll calculate beta. So beta equals to 1.4 minus 0.076 into W by T into Fy by Fu into Bs divided by Lc. So all those parameters we need to calculate. First of all, we will calculate Bs. So Bs equals to W plus W1 minus T. So here W is the outstanding leg weight, 100 mm, plus this is 60 minus 6 thickness, that is 154 mm. Similarly, we will calculate LC. So this is the LC will be equals to 66 multiplied by 4. 66, it is the center to center distance between two bolts, and we'll have the 4 numbers. This is the first, second, third and fourth. So this is equals to 264 mm. So now we can even calculate diameter of bolt hole, that is D0. So D0 equals to D plus 2. We have this diameter, that is 22 plus 2, which is equals to 24 mm. Similarly, we can calculate here A and C. So A and C, which is equals to say W minus D0 minus T by 2 and multiplied by T. So this is the formula to calculate A and C. So W, it is 100 minus 24 minus 6 by 2 and multiplied by 6. So therefore A and C you will get at around 438 mm square. Similarly, we will calculate AGO. So AGO, it is of only one leg. So it is 100 minus 6 by 2 and multiplied by 6. Or you can even say this is actually equals to W minus T by 2 multiplied by T. And this is how you will get 582 mm square. So now we got all the things, and therefore we can calculate beta, which is equals to 1.4 minus 0.076 into W by 2, that is 100 by 6 multiplied by Fy by Fu. We got this Fy by Fu, so this is 250 divided by 400 and multiplied by Bs by Lc. So we got here 154 divided by Lc, we got 264. So if you calculate here, you will get it around 0.94. Now we need to check whether that is less than or equals to. This has to be less than or equals to Fu into gamma mo divided by Fy into gamma m1. So Fu got 400. Gamma mo from table number 5 we have 1.1. Page number 30 it is. Fy 250 and then gamma m1 1.25. So this is equals to 1.41. And this 0.94, which is already greater than 0.7, so we can say this is in the range as per IS code. Now therefore we can calculate TDN. For TDN we have this formula where we need to calculate it beta, and all other parameters we already know. So this is 0.9 multiplied by Fu, it is 400, multiplied by ANC, that is 438. ANC we got here 438, and this is divided by gamma m1 1.25 plus beta we have calculated 0.94 multiplied by AGO we got here 582 multiplied by Fy, this is 250, and that divided by gamma MO, that is 1.1. So if we calculate this, we'll get it around 250.48 kilometers.